And I would like you to write me the electron configuration notation for neon and sodium and magnesium. See any patterns? See a shortcut? So it's almost like a contraction. You have noticed, I think, that this chunk here, which is the electron configuration for neon, is hidden within the electron configurations for sodium and for magnesium. Well, we have this really nice little shortcut. You're going to like this. We say that the electron configuration for sodium is Ne3S1. Neon plus a 3S1. Isn't that nice? We say that magnesium is neon 3S2. So, let's practice the next one. So, what would be the next element going across the row from magnesium? Aluminum. So, let's do the notation for aluminum. Can you do the electron configuration notation? Well, can you go straight to noble gas notation? Try it. Do you need to do the electron configuration first? Okay, that's fine. Okay, so we again look at the configuration for aluminum and say, oh, hey, look, hiding in there is neon. So we can write, oops, wrong color. We can just write Ne 3S2 3P1. Every time you step over one square on the periodic table, what are you doing? Adding one proton and therefore adding one electron. So, let's step over one more. Let's do silicone. Can you write it directly in noble gas notation? Okay. Noble gas notation. This is noble gas notation. Okay, so we can use the noble gases to reference anything in the row after it. So let's do another little example here. Write the electron configuration for argon and potassium, calcium, and scandium. Okay, so you've got all these written out. Do you see argon hiding in any of these?
Yes.
In all of them. There's argon, there's argon, there's argon. So for potassium, we can actually write, okay, so for potassium we can say, well, this is just like argon plus a 4s1. For calcium we can say, well, this is just like argon plus a 4s2. For scandium, what do we need to do? Yeah, argon, and we want to turn those around so that we have the highest occupied main energy level on the outside, 3D1 4s2. And it's common, of course, to write them in the order they fill so that you don't screw it up and put extra electrons in an orbital, but you should flip it when you're done writing. So let's look at a couple trends here. Specific thing that's being added every time? James? Well, you definitely add an energy level. Adam? It's S&P! It's S&P! Every single noble gas ends with a full S&P. Look at that. Full S&P. And this one ends with a 2S and 2P. This one ends with a 3S and 3P. Krypton ends with a 4S and 4P. If you were a betting kind of person, what would you bet xenon ended with? 5S and 5P. So, blah, 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 Charlie Brown's teacher, 5S2, 5P6. Again, if you were a betting kind of person, radon, the nasty carcinogenic, seeps out of the ground in people's basements, noble gas. Blah, 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 blah. 6S2, 6P6. Pretty cool, huh? So let me ask you this. What do you know about noble gases? On the highest energy level they've got, the S and the P are full. Now, not looking at any of this, what do you know about noble gases? They're gases, yes. Yes. Yeah, without looking at that. Not talking about their electrons. Not knowing anything about their electrons. What do you know about noble gases? They don't react. They're noble. They don't mix with the riffraff, as they said in the video. They don't react. They don't form compounds. So, what do you think having a full S and P on your uppermost energy level does for you? We'll pick it up tomorrow. Have a good day.